Okay, let's dive into this. Hello and welcome everyone. आज के इस explainer में हम एक ऐसी कहानी cover करने वाले हैं जो literally epic है. We're talking about a massive story of moving continents, vanishing oceans, and the birth of the highest peaks on Earth. हम decode करेंगे the incredibly complex geological history of the Himalayas. ये सिर्फ पहाड़ नहीं है. These are dynamic, living, breathing structures. So grab your focus and let's get started. But before we even look up at the mountains, let me ask you a really fascinating question. क्या आप जानते हैं कि millions of years ago, parts of modern-day Uttar Pradesh were actually completely submerged under a sea? सुनने में थोड़ा अजीब लगता है ना, like no way, but it's completely true. जहां आज हमारे fertile Gangetic plains हैं, वहां कभी एक vast, shallow marine environment हुआ करता था, called the Tethys Sea. सो कैसे ये समुंदर अचानक गायब हुआ और दुनिया के सबसे ऊंचे पहाड़ बन गए? Well, let's map it all out. So here is our roadmap for today. First up, the lost Tethys Sea. Second, we'll look at the mechanics of the Great Tectonic Collision. Third, the 6 phases of formation. उसके बाद, present-day divisions of the Himalayas. And finally, we'll understand why it is still a young fold mountain. Let's jump right into part 1. The lost Tethys Sea. Let's rewind the clock to about 250 million years ago. हमारा एक massive supercontinent exist करता था, Pangaea. As it slowly broke into Laurasia and Gondwana land, एक बहुत बड़ा water body उनके बीच form हुआ, which was the legendary Tethys Sea. Then, around 180 to 120 million years ago, the Indian plate actually breaks away from Gondwana land और अपना rapid journey north की तरफ शुरू करती है. As it moved from 100 to 55 million years ago, Tethys shrink होने लगा. इस दौरान massive amounts of sediments वहाँ deposit हुए. Finally, by 50 million years ago, the epic collision begins, squeezing the sea out entirely. नई नदियाँ बनी, turning the Tethys into the extremely fertile alluvial plains of North India that we rely on today. Moving on to Section 2, the Great Tectonic Collision. This is the absolute turning point in our geological drama. Just imagine an entire continental landmass sprinting across the ocean. And this brilliantly illustrates the sheer speed of it all. The Indian plate wasn't just casually drifting. It was hurtling northeast at a staggering velocity of 16 centimeters per year. Geological terms, man, this is an absolute sprint. Immense momentum buildwa until it finally slammed right into the relatively stationary Eurasian plate. Now, the real magic happened deep beneath the surface during this crash. Himalayan orogenesis, yani mountain building, kick-started when the Indian plate subducted. Basically, Indian plate, Eurasian plate के नीचे slide करने लगी. It's a crustal doubling hui, physically raising up the massive Tibetan plateau. Under this extreme compression, tectonic activity triggered volcanic eruptions, creating the Dras volcanic arc in the Tethyan crust. The Indian plate effectively closed the Tethys Sea just like a heavy door slamming shut, thrusting all those ancient ocean sediments straight into the sky. That brings us to Section 3, 6 phases of formation. You see, the mighty Himalayas didn't just pop up overnight in one go. Geologists divide their sequential rise into 6 distinct phases. Phase 1, 100 million years ago, Tethys की squeezing शुरू होती है. Phase 2, at 71 million years, the plates fully collide, forming the Indus-Tangpo suture zone, or real mountain building officially begins. Phase 3 brings us the Dras volcanic arc. Then, Phase 4, extreme compression finally raises the majestic Greater Himalayas. During Phase 5, continuous tectonic movement pushes up the Lesser Himalayas. And finally, Phase 6, rivers deposit fresh sediments, leading to the rise of the outermost Shivalik ranges. एक के बाद एक, this was a perfectly structured, sequential uplift over millions of years. Let's shift to the present in Section 4, Divisions of the Himalayas. So let's fast forward to the present day to map out these mountains structurally. अगर हम north से south की तरफ move करते हैं, we have 4 main longitudinal divisions. सबसे north में है the Trans-Himalayas, touching the Tibetan Plateau. उसके ठीक south में, we find the absolute giants, the Greater Himalayas, or Himadri, boasting peaks towering over 7,000 meters, including Mount Everest. उसके बाद आते हैं the Lesser Himalayas, yani Himachal, which is famous for its beautiful transverse valleys. And finally, the southernmost and youngest foothills, the Shivaliks. Okay, let's slow down the pacing significantly here, because the technical structure beneath all this is fascinating. Deep underground, massive tectonic fault lines separate these distinct ranges. The MCT, or main central thrust, is the fault line that separates the Greater and Lesser Himalayas.
यहाँ पर intense compressional forces ने rocks को पूरी तरह से fracture और pulverize कर दिया है. Further south, we have the MBF, or Main Boundary Fault, which separates the Lesser Himalayas from the Shiwaliks. These are the actual tectonic boundaries where the immense pressure of that ancient plate collision is still structurally visible today.
Now, what's really interesting about this comparison is the stark contrast between the western and eastern parts of the mountains. ये एग्जाम्स के लिए भी एक हाई yield topic है. Western Himalayas, जैसे कि जम्मू एंड कश्मीर या हिमाचल प्रदेश में, have a very gradual gradient. यहाँ height धीरे-धीरे बढ़ती है, along with lower rainfall and mostly coniferous forests. But the eastern Himalayas, like in Sikkim and Arunachal Pradesh, rise very abruptly from the plains. They get absolutely hammered by heavy monsoon rains, resulting in lush tropical evergreen forests. This makes the eastern side a globally recognized biodiversity hotspot. लेकिन एक बात सोचने वाली है. Himalayas को young fold mountain क्यों कहते हैं? Let's decode that in section 5. Still a young fold mountain.
हम बचपन से अपनी ज्योग्राफी बुक्स में पढ़ते आए हैं कि हिमालयाज आर यंग फोल्ड माउंटेन्स. बट व्हाट इज द एग्जैक्ट साइंटिफिक रीजन बिहाइंड दैट टैग? लोग अक्सर सोचते हैं इट्स सिंपली बिकॉज देयर हाइट इज स्टिल इंक्रीजिंग. While that's totally true, structurally speaking, the core reason is that they were formed during the Alpine orogeny. Basically, this is Earth's most recent geological mountain building period. यही रीजन है कि हिमालयाज, द यूरोपियन एल्प्स और नॉर्थ अमेरिकन रॉकीज को एक ही रीसेंट हाईली एलिवेटेड जियोलॉजिकल फैमिली में रखा जाता है.
And yes, the incredible fact is that the growth hasn't stopped. The Indian plate is still relentlessly pushing into the Eurasian plate. Because of this continuous, unstoppable convergence, the Himalayas are literally growing as we speak. उनकी height हर साल लगभग 5 millimeters बढ़ रही है. To put that into perspective, geologically speaking, that is incredibly fast. Which brings us to a final, highly provocative thought. With these massive mountains still rising by 5 millimeters every single year, immense stress is constantly building up deep within the Earth's crust. This makes the entire Himalayan belt an incredibly active, highly sensitive seismic zone. The tectonic engine that built these mountains millions of years ago is still running at full capacity today. So what does this mean for the millions of people living in these foothills right now? It's a humbling reminder of the raw, unpredictable power of our planet. Well, that wraps up our deep dive explainer for today. Keep learning, keep questioning, and I'll see you in the next one.